Right on. Just so everyone knows, this is a Linux laptop and it's working, right? Every year, it's the year of Linux desktop, every year. Thank you for that lovely intro. So my name's Sean Porter. I'm known as Porter Tech on the Twitter and on the internet through IRC. My background's in operations, heavy water as a company, which is the D for deuterium, has nothing to do with nuclear reactors. That's a constant problem while going over the Canadian border. We're a 4-year-old business, operation consulting, Chef, Puppet, Ansible. Doesn't matter what the tool is, it's really how you apply them. And that's kind of what our business is based on. We are the company behind Sensu. We've started to back Sensu commercially, and I'll talk a bit more of that later on. So the focus for this presentation, I'm going to talk about the challenges that we're presented as practitioners today and tomorrow, and what that means for us. I'm going to talk a little bit about Devops and infrastructure as code. I'm going to talk about some common pitfalls and failures. That's always the tastiest stuff. I'm going to talk about Sensu and what it is, and then I'm going to talk about Puppet and Sensu together and how they work in practice. So, but before we do anything else, let's talk about software. This is a fantastic quote from Mark in 2011. Software is eating the world. I mean, it's even more true today, and I'm sure it'll be all the more true tomorrow. I think of this in a visual way of like the game or movie Pandemic. You really have no option. It's going to get you in the end and take over the entire society. What's funny is, like, as a society, we have insatiable growing hunger for software. It's becoming part of every facet of your life. Luke, this morning on the keynote, talked about this a little bit. You can't avoid it. And as human beings, we're also addicted to it. I mean, we all check our phones far too often, and we get distracted from tasks every day. What's also really interesting is as software continues to become all the more important in our daily lives, it's also more important for businesses. They're really driving value with software, and businesses completely depend on the sale and support of software. So in the end, we need, as practitioners, to deliver more software, better software, faster and reliably. This is easy, right? No problem. But first, let's talk about infrastructure, a plethora of technologies. So we have to remember that as practitioners, especially at PuppetConf, collectively, we're managing a very wide spectrum of technologies, ones that go all the way back to mainframes. Again, Luke mentioned that there was a customer on Sun OS, and they were perfectly fine. They just want to keep it running. So it's important that we keep that in mind. But no matter what, whether we're running on AIX or IBM System V or Sun OS or Linux, Windows, OS X, really we're running on this, right? There's physical hardware. Doesn't matter whether we're running on bare metal, VMs, containers. It's all this behind the scenes. For the unfortunate few of us, this is what the reality looks like, either from a hardware physical standpoint, we don't have enough cooling, or this is our mental model of our infrastructure, right? So this is a really cool topology graph back from 2013 of Netflix. So this is one, before microservices was the rage, but they were doing it. And I think this topology is very true for most of us. I mean, a lot of our infrastructure looks like this. Whether we're doing containers or VMs or microservices or not, this is what we're dealing with, and it's only going to get worse, right? The scale and the size, the complexity is only going to get ever increasing. So, I mean, this is very overwhelming, right? I think as practitioners, we can get worked up and stressed out about it. But people are successfully operating these infrastructures at scale. So let's talk about Devops. So there's many ways of looking at DevOps and trying to describe it succinctly. This quote is actually one of my favorites from Damon Edwards from the Devops Cafe podcast. Highly recommend giving that one a listen. But he put it as, DevOps is continuously looking for new ways to break down silos, eliminate inefficiencies, and remove the risks that prevent the rapid and reliable delivery of software. Now, what's cool about this is that, there's no mention of culture here, but that's definitely part of it, right? So what's interesting about DevOps is there is actually no end. It's a continuous improvement. So we really need a culture that supports learning in our organizations. So we need things like measurement. How do we know we're improving if we're not measuring these things? You need to move the needles. Things like retrospectives or blameless postmortems. The fine folks at Etsy really do a great job of pushing this. But it's all about delivering better software faster in the end. So let's talk a little bit about infrastructure as code. What is infrastructure as code? I like this quote from Adam Jacob out of the Web Operations book. Enable the reconstruction of a business from nothing but a source code repository, an application data backup, and bare metal resources. Now, bare metal resources in this situation could be anything from actual metal or EC2 instances or Docker images. But it's not just about reconstruction and repeatability. Infrastructure as code technologies, scale effectively to manage, large numbers of hosts at scale. You can apply and revert changes quickly. So this, again, plays to that theme of moving faster. And it's about delivering software faster and more reliably. So it's very in line with DevOps. Basic infrastructure as code workflow. So here, for us, when you're writing your Puppet code, it's all software, right? You code, you review it with your peers, you version it, and then you deploy it. So for Puppet, you design, you come up with an action plan, you write some Puppet code, and then you write some infrastructure templates. Now, this could be something like Terraform or CloudFormation, Direct, or it could even be managing those bare metal resources. That usually happens in parallel with your Puppet code. Not all of it can live within one code base, unfortunately. And then you deploy it. And then you iterate on it. The one interesting about infrastructure as code is that there's absolutely no safeties. So what does that mean? Well, there's nothing that's going to stop you from breaking things at scale. Just as it enables you to move faster and do more changes, apply and revert changes, it allows you to break things as well. Some changes cannot easily be undone. So for example, if you create a file and then if you delete it, it's pretty hard to get that file back without going to backups. Or if you mutate a schema in a database, or you cluster things together that are dependent on host names, and then you want to change those host names, well, your whole cluster state is all messed up. So it becomes harder to revert these things. So there's no safety built into infrastructure as code or Puppet to prevent them. System state and service health. This one's a big one. So this is kind of in line with changes cannot be easily undone. Is systems are living, right? You can set them up with your Puppet code. You can bootstrap a fresh stack. But from that point forward, things are changing. I know there's people preaching immutable infrastructure. But that's more of an ideal or a dream. There's always things changing in amongst that infrastructure. And service health. Some of our infrastructure as code base, or Puppet code, requires a service to be running in order to communicate with the API or make changes to it. So if that thing is down, everything falls apart. An interesting one that many people don't think about is actually coordinating with application deployments is a problem. When you make changes to your config management, to your Puppet code and you deploy it, the next version of the application deployment might need different services or have different constraints based on what's available to it. And the biggest one is erosion, essentially entropy. So after you deploy a system, there's configuration drift, files start filling up, like log files start filling up disk, so things start breaking down in that aspect. So, and then, like third parties, if you're using software repositories like EPEL, and if they're not available, things can start to break down in that regard. So I mean, to take infrastructure as code with no safeties in place, we generally take that tried and true approach of we have a dev, a staging, and a production environment. And we apply our changes incrementally. And when we, as human beings, validate them and check them out, we promote them to the next stage. So what's interesting here in this diagram kind of depicts it is that you're still pushing your code directly to those environments. There's nothing sitting in between. What's interesting is like the first step to start putting some safeties in place in these sorts of workflow is by wrapping these environments in monitoring. So you're essentially automating that validation of your Puppet code, right? So you know that when it deploys, it does and gets the system into the state you expect, and that it stays in that state. This allows you to work more rapidly, right? You can produce more Puppet code, deploy it more rapidly, and it's essentially validating your changes. So you can think of it as improving the feedback loop. You can think of it as providing continuous testing. So this allows you to validate everything, whether your Puppet code's working and your systems stay up and healthy. So let's talk about Sensu and what it is. So Sensu is a monitoring tool. It has a modern architecture. I'll talk about that more shortly. It uses service checks with a simple plugin spec. So those of you that know Nagios and its plugin spec understand how Sensu monitors systems and its plugin spec. It has defined inputs and outputs, and it's very composable. It's definitely a framework, so it provides you all the primitives and pieces you need to build the exact monitoring solution you need for your infrastructure. And it's designed with infrastructure as code workflows in mind. So it's designed to be driven by Puppet as well as work with the Puppet workflow. So it's got a global community of just over 300 contributors. These contributors are everything from submitting code to the application code base or submitting plugins to the vast ecosystem. Which is really fantastic. It's really cool, and it's completely global all over the world. We're still waiting for commits from the North and South Pole, though. It's scalable, monitor tens of thousands of systems, and I'll touch on the architecture and what really enables that. It's commercially backed, so Heavywater, the company behind Sensu, has an enterprise version of it, a little bit more bells and whistles and batteries included version that has things like RBAC, things you would expect for an enterprise version. Has support, training, and professional services. So what platforms can Sensu monitor? So going back to when we were looking at that wide band of technologies, everything from mainframes to containers, we also have platforms like mixed environments of Linux, Windows, FreeBSD. Sensu can run on all of those. So that way you can not only monitor your entire technological evolution, but as well as all the platforms that came along with it. So Sensu as a project started in July of 2011, so it's just over 5 years old, which means that we have a mature community, mature design and approach to how we solve these problems. It also means that we've had enough time to figure out what those primitives are that we need to monitor our systems. So when I say modern architecture, what I mean is that it's designed for dynamic infrastructure. So things like EC2 and Docker. When you have systems coming and going rapidly, a lot of traditional tools that rely on polling-based mechanisms fall short here because when something comes up, it might not even know about it. It might go away. So something might have even gotten to a broken state or mutated something, you totally missed it. Or it comes up, your monitoring system finds it, but then it goes away and then it gives you a false positive and say this service is down, but actually it just got decommissioned or your auto-scaling group decreased the number of nodes. Since it's designed for public networks, so it's designed to operate on like a flat network or vast complex network topologies. So it assumes that everything is public, so it uses SSL and encryption certificates with verified peer just to provide a secure connectivity. What's interesting is because it's an agent-based system, it reaches into the transport, which allows it to traverse all those complex network topologies like over EC2 VPC, your own VPNs, NAT translation, those sorts of things. So the key to the architecture, though, is that you've got monitoring clients that self-register and deregister as systems come and go. So here's a, oh, good, the animation's working. So here's a little animated GIF of how the Sensu architecture works. So we rely on RabbitMQ as the main transport. It's what's providing the secure connectivity as well as the ability to scale out our event processing backend. So Sensu also has a transport abstraction layer. So other services can be used in place of RabbitMQ. But RabbitMQ is the de facto standard. So how Sensu works is it uses routing topologies through Rabbit. So a Sensu server says, I need every machine with a web server subscription to run this check HTTP. The clients that have that subscription pick that request off, do that execution, and then publish their results for processing. The processing backend can be scaled out and in with the size of your infrastructure. So for example, if you're at rest at 300 instances and then you had a large job to process and you go up to 1,000, you could also scale out your event processor, your Sensu servers out horizontally to keep up with that demand. And then when you go back down to your at rest at 300, you scale your Sensu servers back down. And all this data is stored in Redis, which is just a very simple, fast key value data store. It also provides us with some interesting primitives for locking and that sort of thing. And then all the data for Sensu is served up over a REST API, and this allows you to do things like dashboards and CLI tooling. So Sensu is focused around service checks. So what's great about service checks is that they're extremely simple to write and understand. Right? They're easy to grok. Pretty much everyone in an organization, including sales and marketing, can kind of glue together a script that outputs some information, then uses an exit status to indicate severity. What's great is that network guys can do bash scripts. You can even have people writing them in Node.js if you wanted to. The idea is that they provide human-readable messages, right? So when it checks the availability of something and then it determines whether it's up or down, it can provide context. But this doesn't just have to be the server's up or down. It can also be, I reached it within this many seconds, it returned this amount of data, everything looks okay, sort of. So we can actually output some formatted metrics in this case, whether it be perf data, graphite, doesn't really matter. Sensu's capable of ingesting all of it. And then what's great about service checks is that they can actually be mapped throughout the whole service chain dependency, or service dependency chain. So if you have a tiered application that relies on a few other services, you can have checks at every one of those levels. So you can determine exactly if there's an overall failure. You can go down the chain and find out where it's failing. It's just a simple way of reasoning about a system. The Sensu client also provides a UDP and TCP socket locally. So you can do some really funky, cool stuff by writing some JSON to it. So what this example shows is I have a MySQL backup script that I run every 24 hours. And I have it just output some information to the local Sensu client. What this allows me to know is whether my MySQL backups were successful or not, but I can also provide some more context. For example, this run was not successful because it couldn't connect to MySQL. I use an exit status 2 to indicate its critical severity. And now I can be alerted and make sure there's nothing's wrong with MySQL, or I can manually kick off a backup just because I don't want to risk losing that data. At the very bottom, you'll see that there's this concept of TTL. It's time to live in seconds, where this state is assumed to be relevant. So what this means is that in 90,000 seconds, if we don't receive another check result from this backup script, it acts as a dead man switch. So we know that the MySQL backup script didn't even run. So not only can we determine success or failure and gain context around that, we can also tell when external scripts are not running. So what really empowers Sensu as a monitoring platform is its pipeline. So you have, on one end of the pipeline, checks. These are the things that are running out on your infrastructure, determining health and collecting metrics. At the other very end, you have handlers. These are things that are doing actions with that data. So for an example, you might have check HTTP, and at the other end, you might have a Slack or PagerDuty or email handler. And in between, you have what are called filters and mutators. Filters and mutators are fantastic because it allows you to take your data, filter out the noise, and then mutate it into a desired format. For example, if you had a check output graphite plain text, you can have a mutator that drops everything except for the check output, and then we can send that to graphite. So Sensu as a community has a vast array of plugins and extensions. So this GitHub org is full of just over 200 plugins. And each of them have one or more scripts that do various things for those services. What's also great about Sensu is because we're using the Nagios check plugin spec, we can also leverage decades of technical investment in plugins for things like Nagios. So you can actually use your Nagios plugin. So if you're using Nagios and you want to try Sensu, it's quite easy to make the migration because you're using the same monitoring checks. And then Sensu also has several extensions in the community. So these things add protocols to the agent or the backend, whether it be things like StatsD, InfluxDB, or system profiles so you can collect system-level metrics. So all of Sensu's configuration is done with JSON files. So the reasoning behind that is that it's easy for things like Puppet to drive configuration. We can also update configs quite easily. So what's cool about Sensu is it can read either from a single JSON file or many distinct ones, and it deep merges them all together. It makes it easy for Puppet to manage it. Actually, before I move on, so earlier I mentioned on that architecture diagram the concept of subscriptions. So here this check for MySQL replication is targeting any client that has the MySQL subscription. We're running that check MySQL replication script or plugin, and we run it every 30 seconds. What's really cool about Sensu check definitions is you can add as many custom attributes on top of this as you like. Here we have an example called Playbook. So whenever we get alerted or something pops up on the dashboard, we can see this link and we can click on it. It can take us to our wiki, which has steps on how to go about solving your MySQL replication problems. So what does it look like to do Puppet and Sensu in practice? So Sensu has a fantastic plugin. It's on the Forge. The score hovers around 5.0, whatever that means. It's pretty rad. I like it. We have over 101 contributors, some of which are quite prolific. It's a fantastic module for installing and configuring Sensu. So I'm actually just going to walk through a few steps using that module. So first, we're going to start by configuring a Sensu server. Now, this is assuming we have an instance of Rabbit running and an instance of Redis. You can pretty much just choose your own favorite module to make that happen. So this is all that's needed to configure a Sensu server. So we use the Sensu class. The main important things here is that you say server true, and we're also putting an API on this machine. We point it at Rabbit, and we point it at Redis. That's it. So this will start up a Sensu server, and it'll be ready to start issuing check requests and receiving check results. So next, we need to configure a Sensu client. So this is what we need here. So we don't enable the server and API component. By default, the client is enabled. We point it at only Rabbit. So that's the transport, right? So the client only needs to know where Rabbit is. Does not need to know anything else about any other component of Sensu. So this machine in question is a production API server. So we add it subscriptions production and API. This allows us to write checks that target them. So next, so if we think back to that pipeline of Sensu, at the very end we had event handlers. So we're going to configure one first, and it's going to be for Slack. So what's really cool is the module includes a Sensu plugin class. So we can install the Slack handler into the embedded Sensu gem. Ruby gem, and then we can configure this check or this event handler to run that plugin. We give it a timeout of 30 seconds just in case there's a bug in the plugin. We don't want it to hang our event handlers up. And then we give the handler some config, here being the Slack webhook URL, the channel, and the username. So next, let's configure a check. So we want to run an HTTP endpoint check on all API machines. This check is configured on the Sensu server. It's important to know that. I'll touch on that in a bit. So to configure a check on the Sensu server, it looks like this. So we're targeting all the API machines. So we do subscribers API. And our event handler is Slack. So we're going to run the check HTTP plugin on every API box every 60 seconds. And if there's any issues with those results, we're going to notify the Slack channel that we just configured. So what's interesting here, and I've highlighted it in red, is that check HTTP has to be present on those machines that's going to execute this. That's a bit of a problem. It's a chicken and egg problem. So you either need to, on all of your hosts ahead of time, install the plugin, or you have to configure the check and find out which machines need this and needs to be installed via Puppet. So there's another way of doing check execution scheduling. So we just configured one on the Sensu server, and that publishes out those requests onto those subscriptions, and those machines pick off those requests, execute it, and publish the result. You can also configure checks locally on the Sensu clients themselves. So you don't need that pub sub mechanism. And this actually matches really well with Puppet. And the actual only reason why this feature exists is because the Puppet community wanted it to work this way. So they submitted a PR 4 years ago to the Sensu project, and I merged it. So you can thank your fellow puppeteers for this one. So what this does is we configure this on the Sensu client machine. So on an API machine itself, we configure the check. The important distinction is we say standalone true instead of specifying subscriptions. So the rest of the check is the same. And at the same time, we can install the plugin necessary to run. So how do you include Sensu in other Puppet modules? So we can create another class to be included. For example, Apache Monitoring Sensu. And in there, we can configure some checks that are related to monitoring that service. You can also do some really cool things with this Sensu subscription. We can add subscriptions to the box. So for example, if we, on our Sensu server, we had several checks that are all configured to run against Apache, HA Proxy, and a few other web servers, they're targeting those individual subscriptions. On a box, we can add ad hoc subscriptions via this method. You can also add custom client attributes as well. So go back to the pipeline. So we've showed configuration of checks and handlers. We haven't really touched on filters and mutators. If you start looking to Sensu, I highly recommend checking these things out, because these are the pieces that really make it incredibly flexible. So now going back to our simple workflow, we've replaced monitoring with just Sensu. So it's in our workflow. But let's take it to the next level. So many of you are familiar with server spec. If you're not, it's essentially our spec test for your servers. So you can write some code that describes the expected state of your machine. So in this case, we want the HTTP or Apache service to be running on the Red Hat boxes. It should be enabled, and it should be running. But at the same time, we also want to make sure it's configured and properly listing on port 80. So what's cool about this stuff is that you can use it to validate your Puppet modules. There's a few different ways of doing this, whether it be Kitchen Puppet or Vagrant Server Spec, Server Spec SSH. You can really choose your adventure. There's a ton of different options for doing this. What's really cool is that you can really shorten the iterative cycle on working on something like a Puppet module this way, because it allows you to do local development really quick. But what's really interesting is you can take these tests that you're writing to validate your Puppet modules, and you can use them in production as your monitoring checks. So this is pretty cool, because you're not only tightening your loop on developing your Puppet code, but you're also leveraging that again in production to continuously monitor your infrastructure. So what's cool is that there's a server spec check plugin, which basically allows you to just drop these into a directory, and this will go through them, run them all, parse the output, and then provide you with meaningful check result output. So it'll tell you all these passed, or all but this one passed. So to configure that with the Puppet module, it looks like this. So we're saying we're going to run we're going to install the service spec plugin, and then we're going to run that plugin every 30 seconds, looking at this directory for specs. And this is a standalone check, so this would be configured on any machine you want to be running these on. And then if anything happens, we want to be alerted via Slack. So what you end up with is a cool-looking workflow where you're still coming up with your design, you're writing your Puppet code with tests, so your iteration loop is much tighter. You're being able to produce better quality Puppet code. It goes to continuous integration where those tests are run again. That automatically gets promoted, gets deployed. It can still go through dev, staging, production the same way. But what's important is that we remember that we have Sensu monitoring all those steps. And that's what our feedback loop is, right? That's telling us whether Puppet did something we didn't expect, or our service is just died and we're about to get a bunch of trouble tickets from our customers. So this is the main idea, so that you've got your integration tests in both your Puppet testing code as well as production. So in summary, we have more software and infrastructure, more problems. DevOps and infrastructure as code helps us deliver this software faster, but there's absolutely no safeties. You can shoot yourself in the foot in so many ways. Monitoring really must be part of the Puppet workflow. I mean, that monitoring is the safeties. And then, of course, you can leverage your Puppet module tests as that validation in production as well. And Puppet and Sensu have this mutualistic relationship where Sensu can't get deployed without something like Puppet, and then Sensu's providing those safeties for that Puppet deployment workflow. So if you want to learn more about Sensu, I know I didn't talk about it in too much detail, head over to sensuapp.org, or come and talk to me after. Actually, we have 13 minutes for questions. So if you have any questions, feel free to ask now. Yes?
How do you handle when your Rabbit server's down and you can't get a hold of it?
So the question was, how do you handle when your Rabbit server goes down? So Sensu supports highly available Rabbit deployments. So if you deploy a Rabbit cluster of 3 nodes and you tell it of all 3 brokers, if one fails, it'll automatically connect to another in the cluster. So you do have to add more infrastructure to make it more resilient. Sensu is pretty stateless. It doesn't actually store that much data. For the longest time when we first developed Sensu, our strategy around Sensu was if there was a problem with it, nuke it and stand it right back up in 2 minutes and everything rebuilds itself. So yeah, you can make Rabbit HA as well as Sensu's fairly stateless, so it's quick to rebuild and stand it back up.
Does it not really store historical information then?
The question was, does Sensu not store much historical information? It does, in order to provide some context around events. So for instance, we store the last 20 exit status and the latest check result for a client check pair. But if you want long-standing history for things like SLA reporting, you either have to, the Sensu Enterprise product provides more around that, or you send your data into something like an Elk Stack or Splunk, and that can provide you with your rich, long-time reporting.
So are you handling anything like deduplication, or every time it runs and it's clear, you send it clear? So when you're at the realm of having hundreds of thousands of events in an hour, you can eliminate a vast majority of those if the checks are clean.
Correct.
Right. So is that sort of a thing that's built into Sensu, or that's the kind of thing you have to do as you're writing your checks? You need to write in the logic to take into account that you've been clear for the last hour. Maybe you send it clear every hour instead of clear every 30 seconds or 5 minutes.
So the way Sensu does it is that it's constantly requesting those executions every 30 seconds. The plugins can be fairly ignorant. They can just execute and return their status code. Sensu will store just enough information, just enough state, to be able to determine that it continues to be healthy. And so we only have to store so much information about it. When something breaks, we start to store more about it. And that allows us to do deduplication. We can get what's called an occurrence count. So when there's a recurrence of an event state for a machine, for instance, you keep running the check and it's still broken for like 10 days, that count just ever keeps increasing to provide you some more context around it. And then using Sensu primitives like filters, you can reduce when you get notified so that you're not getting constantly paged for an issue you've known about and you've acknowledged.
Are filters giving you something like a stream query? So you can say there's been 10 in the last hour, or there's been 50 in the day, but only, or whatever it is, right?
Yeah.
I've had a string of uninterrupted failures versus I've had an intermittent failure, so many times, which means I know it's broken. That's the kind of thing you get in filters, or no?
Yeah, so filters give you two things. So a basic filter so when your check result comes in, it's determined to be unhealthy. It produces an event, which is a giant blob of JSON, which includes information about the client it occurred on and the Sensu check execution. And then that gets passed to the filter. A filter can look at that event data, and how you configure the filter will say, I only want to be alerted for events that match these attributes exactly, and that will be your Boolean test, whether it gets negated or not. Works very similar to a logstash filter, if you're familiar with the elk stack. And the other way is that it can do evals on the actual content of the attributes. So if you do a filter with an eval attribute, you could say, yeah, for instance, I only want to be alerted if it's been broken for over an hour, or this is the 10th time today it's broken, that sort of thing. You can ask those sorts of questions within the context of the event data. Yes?
Can you talk a little bit about registration and deregistration?
Sure. So the request was, yeah, the request, sorry, I've been doing a terrible job of repeating the questions. Yeah, I'll phrase it in a question is, could I talk about client registration and deregistration? And the answer is certainly. So because the Sensu agents only need to know about RabbitMQ, they come up, they send what's called a keep alive, and that gets sent to Rabbit, and then one of the Sensu servers will pull that off, add that client to the registry, and then expect further keep alives every so often. By default, the Sensu client sends keep alives every 20 seconds. So this gives us a heartbeat for all of our monitoring agents as well, so we know whether a system has actually died or been shut down. So how deregistration works is when we stop receiving those keep alives, what's created is a keep alive event, and that gets handed to a keep alive event handler. So what we can do with this is we can query things like Puppet and be like, hey, Puppet, do you have information about this machine still? It says yes. Okay, well, clearly this is a valid keep alive event. This machine should still be up. So we'll get an alert for that event. But if Puppet doesn't know about it, or it's been decommissioned in Puppet, then we can remove it from the registry, resolve the keep alive event, and nobody gets notified, sort of thing.
What's that integration with Puppet look like?
So the integration with Puppet, so there is a community Puppet integration, which just looks for the Puppet node data. The Sensu Enterprise does a little bit more in that it's looking through your PuppetDB queries and that sort of thing.
Do you have a lot of experience running the server spec stuff as a check in production? And how do you get your spec tests out there? They're living on the node you're checking from kind of thing?
Yeah, so the question was, have I used the server spec stuff to actually monitor real systems? The answer is yes, I've had some luck doing it. The plugin takes care of the actual execution and extraction of useful information from the spec run. The hard part, it's still not a solved problem, is how do I write my Puppet integration tests and also get that code into my Sensu deployment, which generally looks like I have CI that duplicates it and commits it in and then deploys it. It's not beautiful, but it gets the job done. What's also more difficult, though, that adds to it is how do you some integration tests shouldn't be running in production. So how do you make that distinction? So it generally ends up being a more manual process to duplicate those specs. But service spec as a way of describing the expected state is pretty awesome. I'd say in most cases it's well worth the effort.
And you can add OpenBSD to your slide deck if you want, right?
Right on. So yeah, it runs on OpenBSD. So pretty much any BSD, but.
So for the large set of legacy type hardware that's informing via things like SNMP, are there plugins to do SNMP parsing and then effectively normalizing it into the structured JSON or the Sensu?
The Sensu spec?
Yeah.
Yeah, so I mean, well, what's great with SNMP, for the longest story, our story was use Nagios SNMP plugins, right? Because we can leverage that. Again, that's the legacy plugin. So that was always the story. The Sensu community has recently written better SNMP, better. They're just different plugins to do the same things as like pulling devices, receiving traps, and then translating that into something Sensu understands and sending it off. So what's really cool is like Sensu, it's becoming more and more popular to use it to monitor external devices, such as your network infrastructure. Any other questions? Right on. Well, thank you.